So it's awesome to see everybody again back in class, second day. On Tuesday, we were looking at solving linear equations. We pretty much got through that section, but I just want to quickly go through the steps of solving a linear equation. I want to also go through a couple more examples, and then we'll move on to the next section. So I'm going to share my screen. Okay, so you should be seeing the screen in front of you of solving linear equations. And so just a recall, remember really quickly, when you're solving a linear equation, the first thing that you want to do, if your equation has any fractions, we didn't talk about decimals, but decimals also are sometimes really nice to get rid of. But if you have any fractions or decimals in the equation, when solving an equation, we can clear the fractions or the decimals in order to create a simpler equation involving whole numbers. So if you wanted to clear the fractions, remember we looked at the denominators of all the fractions involved in our equation, and we multiplied both sides of the equation by distributing to all terms the LCD of all the fractions. If you want to clear the decimal, basically you have to look at how many digits do we have after a decimal, a whole number, and then you're looking at the most number of digits after a decimal in a number, and to clear that, then you're going to multiply both sides, distributing to all the terms by the lowest power of 10. That will make all decimals and whole numbers. Decimals whole numbers. So for instance, if I have 1.12, I know that there's 2 digits after my decimal, and in order to move over the decimal over twice, I would multiply this by 100, 2 zeros. Where if this was 1.123, I'd have to multiply this by 1,000 to clear my decimal. And again, we don't have to do that when we're dealing with decimals, or if we're dealing with fractions without variables in the denominator, but it just makes things a lot nicer and smoother. Okay, so once we've cleared all our fractions and decimals in our equations, then we went through and we simplified both sides of our equation. And we did that by, if we saw any parentheses, we simplified inside there if possible. We did any distribution properties and combining like terms. And so once both sides of the equation was simplified down, then we used, the addition or subtraction method to move the variables terms to one side and all the terms that didn't have variables on the other side. And then once we did that, we got rid of the coefficient, the number in front of our variable, by multiplying or dividing both sides by that, dividing both sides by that coefficient in front of that variable. But if we had fractions, it was easier to think of it as multiplying by the reciprocal. Okay. So that being said, that was just kind of a quick review of what we were doing. I have a problem that would be similar that you have on your homework that there was a question on. And so let's go through this problem. So it says the manager of a theater wants to know whether the majority of its patrons are adults or children. One day, 5,100 tickets were sold and the receipts totaled $29,514. The adult admission is $7.50 and the children's admission is $4.50. So how many adult patrons were there? Okay. There's multiple ways to solve this. We are looking at linear equations. So I see here, I can set this up as a system of equations, but I'm not going to do that. And we will talk about this maybe, or something similar to this when we get into systems of linear equations later in the text. So I want to try to solve this as just a linear equation, just one variable. So we talked about how to kind of set up our word problems. The first step is that we're going to try to define, or we're going to choose our unknowns and what we're trying to solve for. Let determine what your variable is going to be and what it's going to represent. A lot of times we can do this by looking at what the question asks us. So it's asking us at the end here, how many adult patrons were there? So I'm going to choose, I like to use X, but let's use X to equal the number of adults tickets sold. So normally I would let maybe Y equal the number of children tickets sold. And I guess I could say Y, but I want to represent this Y in terms of X. And so there should be enough information in order to do that. And so let's go back up here. I saw that they told us how many tickets were sold. 5,100 tickets were sold altogether. And so if we let X be the number of adult tickets, we know that we could figure out how many kid tickets were sold by subtracting X from the total number. This was our total. And so if I look at my total number of tickets sold, 5,100, and I subtract off the number of adult tickets sold, that would have to be the number of children's tickets sold. Okay, so we've determined what our variables are going to be in this case, and now we want to go through and we want to set up the equation so that we can figure out what our answer is. And so part B is where I am going to set up my equation or equations depending on the type of word problem. So we know the costs of each type of ticket, and we know how much money was made altogether. So I could figure out how much money was just made off of adult tickets if I look at the price they chose. How much it was cost, how much an adult ticket cost, which was $7.50. So if I do $7.50 times the number of adult tickets sold, which we let be X, that would give me just the income on the adult tickets. Plus I need to put in here the income that we made on the children's tickets. And so children's admission is $4.50. And so if I do $4.50 times the number of children's tickets, which I said was Y, but instead of writing Y, I want it in terms of X. So I'm going to write in here this 5,100 minus X. We know that this should equal the total amount of money that was made, and that was $29,514. Okay, so we have our equation. And so we're going to do a little bit of work and we're going to solve for X. And then we will know what our answer to this problem is. So I'm just going to bring this down. We're just talking about clearing decimals. So if we wanted to clear the decimals, we could. I noticed that I technically don't need that 0 after that 5. So 750 really can just be 7.5, right? Talking about money, it just makes more sense, right, to have the 0 there. But in this case, when I'm just trying to solve for X, I don't technically need that 0 there. And if I wanted to clear the fractions, then I just need to multiply both sides by 10 versus 100, which will make my numbers a little smaller. So I'm going to multiply both sides of my equation by 10. So clear decimal. Multiply both sides by 10. So if I did that, I have this 10 times this, I'm just going to bring it down in black, times this 7.5x, plus I have this 10 times, because it has to be distributed, so it has to go to each grouping, times this 4.5 times this 5,100 minus X equals, and then 10 times this 29,514. Okay, so 10 times 7.5, that just moves over the decimal once, and that gives me 75X. Plus 10 times 4.5 gives me 45 times the quantity 5,100 minus X equals 10 times 29,514. That just adds a 0 to the end, which gives us then 295,140. So now I'm just going to simplify each side of the equation. I need to just do work on the left-hand side. I noticed I need to first distribute the 45 to each term in the parentheses.
I have a question. Clearing the decimal is optional, right? You don't have to do that.
That is correct. So we didn't have to clear the decimal, but so that was fine, and I wouldn't knock off any points for not doing that. And in the end, though, we should still get the same result. Good question. So distributing this 45, I'm going to first bring down that 75X plus 45 times 5,100. I do expect that you know how to do that without a calculator, but you can use calculators on the homework and on the end of the chapter test, but you may not be able to use it in an in-class test. I would probably make it so the numbers fell out so much easier than this, because I don't want you to have to spend so much time doing your arithmetic properties and instead showing me how to do the algebra. Okay, so we have 45 times 5,100 is 229,500 minus 45X equals this 295,140. Combine like terms. So we have two like terms on this left-hand side. We have this 75X minus this 45X, which is going to give me a 30X. Plus 229,500 equals 295,100 and 140. I noticed that now that it's simplified on each side, it would be easiest if I keep 30X on the left-hand side. So I want to get rid of that 229,500, and I can do that by subtracting this number on both sides of my equation. And so when I'm doing that, I'm going to bring down my 30X. This is equal to, I'm just going to do subtraction, 0 minus 0, 0. 4 minus 0 is 4. Can't take 5 from 1, so I'm going to borrow. 11 minus 5 is 6. Can't take 9 from 4, I'm going to borrow. So 14, oops. Yeah, sorry. That was a 5. It now looks like an 8 when I crossed it out. So just had to go back and look. Okay, so 14 minus 9 is 5. 8 minus 2 is 6, and 2 minus 2 is 0. Okay, so I get 65,640 if I subtracted that number on both sides. And then last but not least, I got to divide both sides by 30. So again, I really do expect that you can do this. Let me just do it on the side really quickly. So 30 doesn't go in, goes into 65 about twice, which gives me 60. Bring down my 5. This could help you, just kind of a review of doing long division, because later on in the course, we're going to be doing division of polynomials. And it's helpful to remember how to divide just with numbers when we get into that portion of the course. So 30 goes into 56. It goes in there about once, 2 times is too much. So 56 minus 30 is 26. Bring down our next number, 4. 30 goes into 264. Well, 3 goes into 26 about 8 times, so I'm going to try 8. So 8 times 30 is 240. 264 minus 240 is 24. Bring down my 0. 30 goes into 240 evenly 8 times. So I get x is equal to 2,188. So it's important to realize, does your answer make sense? So for instance, if I had gotten a decimal here or a fraction, that wouldn't make sense because it wouldn't make sense to sell a partial ticket, right? And so I would probably think that something went wrong there. The other thing is, if I got a number, I got 2,188. I know that 5,100 tickets were sold. If I got more than that number of tickets, that wouldn't make sense, right? And the other thing is that wouldn't make sense if my answer was negative. So just kind of see, does that answer make sense for this type of word problem? And you can see if maybe you did some errors wrong or not. So this was just asking how many adult patrons there were. So we know that part B and part C are answer. So X equals 2,188. And because it's a word problem, I'm going to specify sometimes units, but I'm going to put adults. Tickets sold. If I really technically wanted to, I could definitely figure out how many children tickets were sold, right? By going back in here. I know that, again, 5,100 tickets were sold. And if I subtract off the number of tickets that of 2,188 of adult tickets sold, we can even go a little further and say that Y is equal to 2,912 children tickets sold. So hopefully that clarified how to do that problem. So let me just pause the recording, see if there's any questions, and then we'll continue. Okay, so the next thing that you need to know from this section in your textbook is how to solve for a particular variable in an equation when you have more than one variable. You're going to do this process the same as if you were doing this with just one variable in there. So first thing you want to do is clear the fractions if we have it, and we do have fractions within this equation. And let me just read that equation for you. So it says solve the equation. The letters A, B, and C are constants. And we have X divided by A, and then we have plus X divided by B is equal to C. And we have to put on some stipulations that A can't equal 0, B can't equal 0 because we can't divide by 0. And they tell me that A can't equal negative B. Okay, so I want to look at all my fractions within the equation. So I only have 2 fractions within the equation, and I want to find my least common denominator. And so I'm not sure what my numbers A and B are. And so our common denominator can be A times B. So I'm going to look at multiplying AB to both sides of the equation. And we have to distribute that AB to each term on each side of the equation. And so when we distribute this AB to this X over A, notice that the A's cancel when I distribute to the first term. And so if the A's cancel when I distribute to the first term, I'm just left with B times X. Plus, so now when we distribute this AB to the fraction X over B, B's are in common in the numerator and denominator, so they're going to cancel. And so we're just left with the A times X equals A, B, C. Okay, so we're solving the equation here for X. So there's what we want to do is we want to look at all the terms that have an X in our equation. And so notice both terms that have an X in our equation are already isolated on one side of the equation, and the other side doesn't have that variable X in there. And so we've already gotten all the terms that we want with a variable on one side and all the terms without that variable on the other side of our equal sign. We don't know what A and B are, so I don't really know how to add these. But I do know that they both have an X in common and that I can factor it out of both of those terms. So we have X parentheses. Well, I pulled an X out of this first term, I'm just left with this B, plus pulling out an X from AX, I'm just left with A. This is equal to ABC. So now just to get that X by itself, I can divide both sides by our parentheses of B plus A. So if I divide both sides by that parentheses of B plus A, notice that we're gonna get this to cancel here. You're just left with your X is equal to this ABC all over B plus A. I cannot simplify this. This is as far as this goes. So it's common error for students to want to simplify here, maybe that B and the A, but I have more than one term in the denominator because of the plus in here. And so I don't really have any like factors in this case. And so that's as far as we can take it again. And so X is ABC, that quantity all over the quantity B plus A. Okay, so the next example, we have capital A is equal to 1/2 times H, and then the quantity, so parentheses, capital B plus lowercase b, end of parentheses, and it says that we want to solve for capital B. So this is actually the area of a trapezoid. A lot of these problems, or a lot of times when you're working with word problems, you might have multiple variables and you want to solve for one in terms of the other. And so if we want to solve for capital B here, a couple of things that we can do. We could clear the fraction. There's only one fraction in here. So we could technically multiply both sides by 2. Right? So if I multiply this side by 2 and this side by 2, notice that the 2's cancel, so I no longer have a fraction within this equation. And so I can rewrite this 2 times A, so 2 capital A equals little h, all times that quantity B plus capital B plus little b. Well, I don't know what capital B and little b are, so I can't combine them. They're not the same variable. But I also see that I don't have a plus or minus between this h and the parentheses. That tells me that I need to use the distributive property and distribute h to each term inside the parentheses. So bringing down the other side of the equation, 2a is equal to, this will distribute the h, we get h times capital B plus h times little b. We're trying to solve for capital B, so we want all terms without capital B to one side of the equation. So that means I need to get rid of that positive h beyond that one side, and I can do that by subtracting h lowercase b on both sides. Well, 2a and minus hb are not the same, so I'm going to rewrite that. So I have 2 capital A minus H lowercase b is equal to H times capital B. So now I can get rid of the H in front of my capital B by dividing both sides by H. So I find that my capital B is equal to 2 capital A minus H lowercase b all over H. I would leave it like that, but notice that this is an equivalent form. There's only one term in the denominator, so we could break down capital B as rewriting each term in the numerator over our denominator. So 2 capital A over H minus lowercase b over H. And so notice if that's the case, those H's are going to cancel in that second parentheses. They're the same answer, just different forms. I like the first way better though.